we're looking at how we can create linear functions, linear equations. When two items are said to be related linearly, one depends upon the other in a linear fashion, we can create an equation that expresses that relationship by creating an equation of the form y equals mx plus b, where m is the slope of the line related to that equation and b is the y-intercept. And we've already looked at two circumstances that we sometimes encounter. Sometimes we will be given the slope and the y-intercept directly, and we can just plug them in and create our function, create our equation. Sometimes we're given the slope and a point. In the last video, we looked at how we can take that information and create our linear function to relate those two items. In this video, we want to look at the third scenario. What if we're given 2 points? How can we take those 2 points and use them to find the equation that relates those two quantities? And let's stick with our anvils and our costs for producing those anvils. So x represents the number of anvils, and y is the cost. And we might even use the cost function notation, c of x. So let's suppose one day of production, we made 10 anvils at a cost of $2,850. On another day of production, we made 44 anvils at a cost of 40 anvils. Get my figures right here. 40 anvils at a cost of $3,900. In effect, we've been given 2 points. Anvils are the x value. Cost, that's the y value. So we've been given 2 points that would be on the line defined by the equation that we want to find. Well, if you have 2 points on a line, one of the things that you can find of the line is the slope. The slope is the change of y over the change of x between any 2 points on the line. So we can take the change of y, 3,900 minus 2,850, that gives us 1,050. 3,900 minus 2,850 is 1,050. That's the change of y. That's the change of cost over the change of x. 40 minus 10 is 30. X is the anvils. So this is cost per anvil. Dollars per anvil. That's the unit cost. That's the slope. And 1050 divided by 30 would give us 35. So we now know the slope. So we now know our equation looks like y equals 35x plus b. And we're really kind of back to the situation that we looked at in the previous video. We now know the slope. We can take one of these points and plug the value in for y. In this case, we'll use the 3,900. Plug the value in for x, 40. And that produces this linear equation in one variable that we can solve for b. If we take 35 times 40, that gives us 1,400. So we have 3,900 equals 1,400 plus b. b equals 2,500. Our equation y equals 35x plus 2,500. Or c of x, if you want to use the function notation. Cost. Give a letter as the function name that is indicative of what the y value is. It's the cost. So here we've seen if we are given information that we can use as 2 points, we can find that equation. We can find that function by first finding the slope, taking that slope along with one of the point values x and y, to find the B, and we found our linear function that relates cost to, in this case, number of anvils being produced. So we have these three scenarios that we are often confronted with. So when we're confronted with a new situation, we may want to ask ourselves, which of those scenarios do we have? And can we then take that approach to find the linear function that we desire?